Hello everyone and welcome back. In this video we use GeoGebra to visualize the Riemann lower sum and Riemann upper sum. We will first examine them separately and then compare them together to understand how they approximate the definite integral. Let's begin. On the screen we have the graph of continuous function defined over a closed interval. Our goal is to estimate the area under this curve. First, the interval is divided into several equal subintervals. These partitions will use to construct the approximating rectangles. Let's start with the Riemann lower sum. GeoGebra constructs one rectangle on each subinterval. The height of each rectangle is chosen as the minimum value of the function on that subinterval. As you can see, every rectangle remains below the graph of the function. Therefore, the total area of these rectangles is less than the exact area under the curve. This is why it is called the lower sum. Now observe that what happens as the number of partitions increases. The rectangles become narrow and the approximation become more accurate. The lower sum gradually moves closer to the true area. Now let's construct the Riemann upper sum. Again the same partition is used. This time the height of each rectangle is determined by the maximum value of the function on each subinterval. Notice that every rectangle exceeds above the graph. As a result, the total area of these rectangles is greater than the exact area under the curve. This is known as the upper sum. Increasing the number of partitions produces thinner rectangles and a better approximation. Now let's display the lower sum and upper sum together. The lower sum provides an underestimate of the area while the upper sum provides an overestimate. The actual area under the curve lies between these two approximations. As the number of partitions continues to increase, both approximations move closer to each other. Eventually, the gap between them becomes extremely small. In the limit, both converges to the same value, which is the definite integral of the function over the given interval. Thanks for watching. If you enjoyed this visualization, please like the video, subscribe to the channel and stay tuned for the next session.